All right, shall we begin?
Sounds good.
All right. Greetings, everyone. Welcome to our town hall, Conceptualizing Interagency Carbon Information, Monitoring and Decisions. My name is Gyami Shrestha. All right, shall we begin?
Sounds good.
All right. Greetings, everyone. Welcome to our town hall, Conceptualizing Interagency Carbon Information, Monitoring and Decisions. My name is Gyami Shrestha. I'm the director of the U.S. Carbon Cycle Science Program Office at the USGCRP. This is a joint town hall of the Carbon Cycle Interagency Working Group, Observations Interagency Working Group of the USGCRP, and several scientists from the federal agencies. In this town hall, we are going to be exploring questions such as what would an interagency carbon information system look like? What is its utility and how could it be sustained? Next, Ben Poulter will provide a brief overview. Ben?
Okay, thanks, Gyami. Yeah, thanks everyone for joining the town hall. We have 3 moderators involved. So myself from NASA Goddard, Gyami and Lori Bruhwiler from NOAA. And then we have a fairly sort of wide range of panelists that we'll be hearing from. We'll have a presentation by myself and then a presentation by Richard Engelen on the European Union's Copernicus atmospheric monitoring system, and then informal updates from the various agency representatives, and then a open discussion and Q&A. So just some brief context. I'll speak for maybe 5 minutes and then pass this over to Richard. Some brief context for this is that over the past 2 years now, we've really seen the urgency and the need for better coordination across agencies in terms of greenhouse gas observations and monitoring. The COVID-19 sort of Earth system experiment really demonstrated that we do have the capacity at the moment to monitor and detect changes in emissions and atmospheric concentrations of CO2 and methane and N2O in response to socioeconomic changes. For example, there was about a 5 to 7% drop in CO2 emissions during 2020, when most of the work from home and shutdown orders were implemented. And these emission reductions were detected by the OCO2 greenhouse gas satellite as a reduction in the expected growth of CO2 concentrations in the atmosphere. But despite the drop in emissions, 2020 actually had one of the largest growth rates of CO2 on record. So you can see in the bottom left panel, the bar on the far right shows that the growth rate was about 2.4 ppm despite the drop in emissions. And so there's a need to understand with lower latency the dynamics and the interplay between emissions and concentrations, and what the role of the biosphere is playing in this dynamic. And then secondly, as the Paris Agreement moves toward implementation from rulemaking, there's a need for these monitoring systems to be integrated to better understand the effectiveness of emission reductions, and to help us prepare for the global stocktake in 2023, the first of many that will take place on a 5-year cadence, to also, well, with the intent of understanding emission reduction policies. So the panel that we have today has representatives from the U.S. Global Change Research Program. The USGCRP coordinates research across 13 agencies, and we have several of these represented. The USGCRP also coordinates the U.S. Carbon Cycle Science Program, which carries out activities like the State of the Carbon Cycle, and also the National Climate Assessment, which is currently in its 5th phase. The USGCRP also plays a role internationally, sort of first through the US group on Earth observations, and then through activities like GCOS or CEOS, the Committee on Earth Observation Systems. So I think we're all aware of the investments that US agencies have made over the past several decades in terms of building up individual monitoring systems. This is just an example of many of the programs that have been set up at NASA, for example, with the greenhouse gas satellites that are in orbit, OCO2, OCO3, some of the ecosystem structure and function missions like JEDI, and then other programs related to sustained land imaging. At the same time, NOAA has several in situ and airborne programs, as well as data assimilation systems that are able to ingest the various observations to come up with reanalysis products on greenhouse gas information. Agencies like the Forest Service contribute to the Forest Inventory and Analysis Program, USDA with the soil monitoring program, and these activities feed in to the work that the EPA carries out with the National Greenhouse Gas Inventory that's submitted to the UNFCCC. Also, over the past several decades, there's been plenty of reports coming out from the national academies, from things like the NASA Decadal Survey and elsewhere that have recommended for a more integrated approach to how the agencies work with one another to measure, monitor, and integrate the information from these various data streams. The Paris Agreement emphasizes the need and provides a mandate in some sense for implementing these programs and maintaining them as in terms of a sustained operational system. So over the past year, and we'll discuss some of this with the panel, there's been quite a few activities that have been launched, particularly in the context of the US rejoining the Paris Agreement. There are activities related to the North American Carbon Program through the National Science Implementation Plan that recommends for interagency coordination on greenhouse gas monitoring and data assimilation. NASA has launched a new Earth System Observatory concept, which will integrate measurements from 4 new missions emerging from the 2017 Decadal Survey. OSTP is pushing for an acceleration of science and to make this science more application ready to inform policy. And recently, the Carbon Cycle Interagency Working Group has recognized interagency operational greenhouse gas observations as a work stream to help socialize and further develop this concept. And then we'll be hearing from Richard on the international side of several of the activities that have led to the development of a prototype operational system for the Copernicus atmospheric monitoring system. So as mentioned, we in the US have built capacity across the in situ, the airborne, and the spaceborne programs. We currently have several 2 greenhouse gas satellites that are in orbit, and there are plans for geostationary observations to be made through NASA's GeoCARP program. On the NOAA side, there are the airborne observations and the various other networks that feed into NOAA's GML program that we'll be hearing from Arlyn Andrews in a moment. And then we have various ground programs related to Ameriflux and FluxNet and NEON. There's also discussion about how such a network or integrated system would work across different spatial scales, integrating information from site level, from urban systems, and up to the continent and to the globe. And so we'll be hearing from NIST, from Anna Karion, about some of the activities that they're carrying out in maintaining and contributing to these observing networks. And then lastly, such an interagency coordination around greenhouse gas observations and monitoring would serve various stakeholders. And so this figure is taken from one of the publications from the Copernicus program that really illustrates that these stakeholders emerge at various scales both spatially and through time, where we have individual operators that have a need for this type of information, at shorter timescales to detect leaks and point source emissions, all the way up to stakeholders working at the global scales and implementing policies. So we'll move on to Richard's presentation, and then we'll work through the various perspectives from the panelists, and then move to discussion. Thank you.
Okay, thank you. Okay, it should be visible now, I hope.
Yes, looks good.
So thank you, Ben, for the introduction, and thank you very much for the invitation to this town hall meeting. And it's a pleasure to give a brief high-level overview of some of the activities we are doing within Europe, and especially within the Copernicus program. So I'll first focus a little bit about the background of Copernicus itself, and then move more towards our current activities and plans for CO2 and methane emission monitoring service component as part of Copernicus. So for those of you who don't know or are not aware, Copernicus is a large EU-funded program, an Earth observation program that consists of both satellites, so a whole series of satellites monitoring land, ocean and atmosphere, but accompanied by a set of services. So this is a really important component of Copernicus, that we combine not just the observations, but also try to add value to these observations by, for instance, involving modeling. In case of the atmosphere monitoring, we have forecasts of air quality, forecasts of global pollution, but this applies to all the services. So it's really a combined program as part of the EU space program that also includes a large service component. It's in first instance a space program, but of course we don't forget about the in situ component. So here we try to work where possible with the various networks to make sure that we combine all the information we have in terms of monitoring the Earth environment. And just as an example how this works in practice, so this is for the Copernicus Atmosphere Monitoring Service, which we have implemented at ICNOAF, the European Weather Center, on behalf of the Commission. We are also responsible for the Climate Change Service, but I'll focus here on the Atmosphere Monitoring Service, because that's also where the greenhouse gas monitoring will sit on the longer term. So the whole idea is to move from observations on the left, satellites and ground-based observations. And for instance, this is a figure of the air quality network in Europe. Combine it with our modeling, both at global and regional scale. So we have a global system running at ICNOAF, looking at more long-range pollution. But then we have an ensemble of air quality models distributed over Europe, but all using the same boundary conditions, the same emissions, etc., to come with an ensemble forecast for the next 4 or 5 days. So this is the core of the service, but then we also interact very strongly with what we call the downstream service component. So this can be companies, public authorities that pick up our data and fine-tune this for their target user group. So again, this is also very important. And in my next slide, I just show you some examples of how our CAMS information is actually available. Might not always be visible, but we really try to connect to basically make what we do accessible to a really wide range of users through different means. In terms of history, this didn't just happen. There was really already in 1998 a long-term vision about how can we set up a global monitoring system for the environment. So this started with the Baveno Manifesto. This was a document bringing together the ideas, which then got everything started. And there's a whole series of points here along the arrow. We changed names a few times. Initially it was GMES, then it slowly moved into Copernicus. And there was a lot of research and development along this path as well. which is really important because operational services don't just happen overnight. They take a lot of preparation and making sure we convert the science into operational services. So the real operational component of Copernicus started in 2014. So this is now already 7 years ago as well. So we have some experience now providing these operational services. But yeah, there was a long history before that. Looking ahead, we really have an exciting future. Of course, we have relied on many satellite missions over the past decade or so, and actually quite a few coming from the US, which we're very grateful for. But now Europe is also investing in their own satellites. An example is, for instance, Sentinel-5P Tropomi. But if we look in the years ahead, we'll have Sentinel-5 as a polar orbiter, Sentinel-4 as a geostationary satellite, and then also the C2M mission, all focused on measuring the atmospheric composition. So it's really exciting, but it also immediately raised the question, well, how can we best exploit this wide range of data? We also see this very importantly as our European contribution to the international collaborations, so GEO, GCOS, CEOS. We also work through WMO. We don't want to do this on our own. We really want to collaborate internationally with various agencies and other stakeholders. So then we come to the ambitions for greenhouse gas emission monitoring. This basically started with the Paris Agreement, but then also with the new commission, which is now in place, governing the EU. They launched the European Green Deal, which is broader than just the Paris Agreement. So there's really strong ambition to see how we can improve in making sure we don't, that we mitigate our emissions and do this as strongly as we can. But it's also very important for us to monitor this. So here, the Commission President Ursula von der Leyen immediately expressed the wish to use the Copernicus program to build a monitoring system as part of all these ambitious activities. So here again, we have a timeline starting in 2015 with a few expert groups that came together and thought about, well, what do we need to do? What does it take to build such a system? Resulting in a few reports, blue, red, and green report, as they are often called, which are available to anyone. Focusing on the science, the green report actually focusing on the in situ requirements, and then alongside the development of the C2M mission, and there's, for instance, a mission requirement document that first appeared in 2018. Everything also supported by research and development projects. As I mentioned before, this is really important. So we had a few C2 human emissions project, Verified project, which is still ongoing, COCO2 project, which is running now, all leading up to the ultimate system we want to implement as part of the Copernicus Atmosphere Monitoring Service. The challenges we face, and this is probably not new to any of you, but when we look at satellite observations, they don't measure emissions directly. They measure the impact of the emissions on the atmosphere. And they also see the total impact of both anthropogenic and natural effects. So going from what we can see on the left with the satellite to what we want to know, the emissions on the right, this is really where we see strength of Copernicus, because we're bringing the Earth system modeling component through the services, integrating all the information we have to provide the policy relevant answers in the future. So this is the implementation as we see it, very high level. This figure is actually also being taken up now by CEOS. It's basically based on how we have been working for decades already, for instance, in numerical weather prediction, but also in the last decade for air quality, combining the different information streams, observations, prior information that we already have in both global and local integration systems, data assimilation systems to provide the outputs, and a very important also a link to the policy sector. And coming to that, I think this is my last slide. For us, it's also very important while we're developing this to really interact with the user community. We really want to co-design a portfolio. We have IDs, we have current practice. For instance, on the top right is an example from the Climate Change Service, where we have interfaces that convert the enormous amounts of data into figures that can be easily interpreted by non-experts, or at least non-data processing experts. But this is something that we have to develop together with the users. So this is, again, where we try to work internationally as well, learn from each other, and try to reach out to the different communities together to see how we can best address the policy needs in the coming decade. Yeah, and this is my final slide, just to emphasize again, we have our European emphasis on the left, but we really want to work internationally as well. We are trying to reach out with the different infrastructures and different countries involved, because we have to do this together in the end. So thank you very much.
Okay. Thanks, Richard. I will share my screen. So now we will sort of step through the different panelists that we have available, and hear from them and their sort of own agency perspectives on greenhouse gas monitoring and observations, and where things are moving in the future toward something like an interagency coordinated observing system. And we'll start with Arlyn Andrews from NOAA's Global Monitoring Lab.
Hi, thanks, Ben, and thanks everybody for attending. So Monika Kopacz would have represented NOAA, but she couldn't be here today. So I'll do my best. We do not have our greenhouse gas efforts within NOAA are distributed across several different line offices, and it can be confusing for people on the inside like me, and especially confusing for people on the outside. So I'm just going to mention a few of our top level sort of activities that are going on right now, and then speak very briefly to how we might be able to expand that in the near term and possibly in the longer term. And so NOAA has much of our work on greenhouse gases has been under the auspices of NOAA research. So Monika is leading a program within NOAA's Climate Program Office. The Climate Program Office sponsors a lot of research and observations, including the Global Greenhouse Gas Reference Network, which is our atmospheric measurement network that has produced the long-term records of greenhouse gases, CO2 and methane, but also a host of minor greenhouse gases since the 1970s. And we maintain the Mauna Loa Observatory that was started by Dave Keeling. So that's really foundational. And our laboratory, the Global Monitoring Laboratory, also has the Carbon Tracker CO2 data assimilation system, which has been quasi-operational since around 2007. And so that's producing annual estimates of the global carbon budget that are used to try to understand really ecosystem feedbacks at this point primarily. And then NOAA obviously has a huge ocean program, and the NESDIS line office, which is separate from OAR, which is the research branch. NESDIS does not have any, that they're responsible for the satellite observations, the sustained long-term satellite observations of NOAA. And so ultimately, if the US commits to long-term greenhouse gas measurements from space, they would most likely live in NESDIS. And at this point, they're working to develop strong partnerships with NASA and the ESA and JAXA in this realm. They already have strong partnerships, so that we can start to lay the groundwork for an operational data assimilation capability that would provide estimates of ecosystem fluxes and also function in a way that is similar to what we heard from Richard. And so I've taken a lot of time. I do just want to say that NOAA has this kind of operational role. So NASA has very much an R&D role and has done just amazing things in terms of developing measurement technologies for the greenhouse gases. EPA has a a regulatory role, and they make measurements of pollutants in urban areas, et cetera. And this space for what an operational greenhouse gas observing capability looks like is evolving. And I'll stop there.
Thanks, Arlyn. And now we go to Barry Lefer, who's the program manager for tropospheric chemistry at NASA.
Thank you, Ben, and thank you, Ben and Richard, for those wonderful presentations. And Arlyn did a great job of explaining how NASA is making space-based observations as well as some ground-based measurements and some calibration validation efforts to understand our satellite observations. And we also are doing some global modeling and assimilation of the OCO2 and OCO3 data with our ecosystem models. And, you know, we fully support this idea of coming up with an integrated Earth system observations and modeling system for the by the US federal government, because every agency is bringing different pieces of this puzzle to the table. And as Arlyn said, NASA is clearly not an operational agency. Our job is to develop these new technologies and make sure they're usable to the stakeholders. And we want to work with these other agencies. And as my role as a co-chair of the USGCRP Observations Interagency Working Group, this is the kind of things we work on all the time, trying to get the federal agencies to work together. And we've also endorsed the work plan that was suggested to have an interagency carbon information monitoring and decision system in place. And I'm going to let Mike talk a little bit more about the carbon measurement system at NASA.
Thanks, Barry. Yeah, so next is Mike Falkowski, who's program manager for terrestrial ecology program at NASA with Hank Margolis, and is also heavily involved with NASA's carbon monitoring system. So
yeah, thanks Ben, and thanks Barry for those comments and the presentations before this. And so I'll just speak. I don't need to add a whole lot from the NASA perspective in addition to what Barry said, but I will briefly talk about NASA CMS. And for those that are not familiar with NASA CMS, the overarching goal is to prototype the development of capabilities necessary to support stakeholders for carbon measurement and monitoring, and specifically focused on stocks and fluxes. And I'll emphasize that the goal is prototyping. As Barry mentioned, and as Arlyn mentioned before that, you know, NASA is not in the business of operationalizing these things. And so CMS is really meant for development and prototyping of these systems with a strong link to stakeholder needs. And so, you know, we just had the NASA CMS meeting, the annual meeting a couple of weeks ago, and I would say it was wildly successful. It was really interesting to see how far we have come along over the lifetime of CMS. And so it's really exciting to see, especially for me, it's exciting to see the level of stakeholder engagement and the level of support the stakeholders are getting through NASA and other federal agency data products and models to support their needs in terms of carbon monitoring. You know, so in terms of the future, you know, we fully, CMS is congressionally mandated, and it's now backed by funding, I believe. And so for the foreseeable future, we expect CMS to continue in its current form. You know, we'll adapt it in terms of meeting sort of cutting edge research and stakeholder needs. But for more or less, you know, the goal will still be to develop and prototype CMS systems. It's never going to be the goal to operationalize. But as Barry said, you know, we at NASA, we are very interested in supporting stakeholders and working with our other federal partners in developing a operational CMS however we can. So I'll leave it at that. We can come back to CMS in the questions if we want to.
Thanks, Mike. So next we'll hear from Anna Karion at the National Institutes of Standards and Technology.
Hi, thank you to the organizers for giving me the opportunity to be part of this panel. A lot of what Mike was just saying about CMS can be echoed sort of in what NIST has been trying to do. We're working in the urban space, looking at greenhouse gas emissions in urban areas. So we've funded 3 different what we call urban test beds, but the idea is that in LA, in Indianapolis, and more recently in the Northeastern US, we're funding both airborne measurements, in situ, and tower measurements, tower-based measurements that are sort of long-term. In Indianapolis, they're more than 10 years old. So some of these urban projects actually do have some longevity. Salt Lake City also has a really long urban, a history of urban sort of monitoring by making the greenhouse gas measurements. But we're also interested in, using these test beds as laboratories, and we see our role as, funding R&D, but with the goal of eventually transitioning to something operational, and thinking about how that can be done in terms of the modeling piece, as well as the measurements piece. But the idea is to focus and develop and prototype. We welcome collaborators to all these different cities to take advantage of the measurements that we're already making. And a lot of these urban areas also, these projects have been spurred by, people who are local to each city. So university researchers who may be in a specific locality, and also trying to engage stakeholders, national but local stakeholders, which is a lot of times easier done when you're, actually in that city and you have a stake in it versus from somewhere far away. So again, these cities that I highlighted on the left there, it's not, NIST is funding some of the work. Obviously, the NOAA AC4 program has a big piece of this as well, and they've funded sort of trying to get the different urban researchers to work together. Another thing, I think all the people working in this space are interested in linking better with air quality networks that already exist, and there's a lot of interest from the EPA, and especially when you start working with local stakeholders in cities, that's what they care about a lot. We're also, there's a lot of research going on in the satellites, and that's not something NIST is doing, although we definitely would be interested in looking at how the satellite data can be used to look at urban emissions, which has started to happen a little bit more and more, but especially on these point source emissions where, the private sector has really come into this realm pretty quickly. And, both as a customer, like companies trying to understand their footprints, as well as companies launching satellites and providing products. And I'm not sure where there's space there for the federal agencies to be involved in that, but I think it should be somewhere. That's not something we at NIST are doing. So I guess that's all I wanted to say. Just we do want these urban test beds to be sort of integrated into the larger greenhouse gas observing system somehow. Again, even though they're not operational, we do try to maintain the data to be public and to be on the same sort of scales, so that if someone were to, try to analyze the data together with other labs' data, that would be something that one could do in a national context. So I guess I'll leave it at that, but thank you.
Okay, thanks, Anna. And then our last panelist will be Melissa Weitz from the Environmental Protection Agency, working on the National Greenhouse Gas Inventory. And then we'll have questions and discussion. Melissa.
Hi, everyone. Thank you. I am with EPA's Office of Air and Radiation, and I work primarily on our National Inventory of U.S. greenhouse gas emissions and sinks. I'll note EPA tracks greenhouse gases primarily through two complementary programs, our Greenhouse Gas Reporting Program and our Greenhouse Gas Inventory. I'll give a super brief overview of both of those. The Greenhouse Gas Reporting Program is our annual facility level reporting required under the Clean Air Act. Under that program, I think about 8,000 facilities are reporting data to us, and they use methods prescribed by the regulation from the program. So that can include direct measurements or engineering calculations or emission factors. Detailed information as reported by each facility is available on our website. So that includes types of equipment, emissions by equipment, as that's a pretty valuable resource for people looking at specific facilities and trying to figure out kind of what emission sources are present there. The other program, the National Greenhouse Gas Reporting or National Greenhouse Gas Inventory, the one that I work on, is our annual report to the United Nations Framework Convention on Climate Change. We've been developing this report since some point in the mid 1990s. Every year we report on a time series from 1990 until the most recent year for which we have data. So we right now are working on our estimates for 1990 through 2020. The inventory is compiled using a number of data sources, often using a lot of data from our greenhouse gas reporting program. So taking that facility level data, scaling it up to the national level. We work with other agencies on the inventory as well, including agencies present here. So we've worked with NOAA to incorporate for the first time estimates for coastal wetland emissions. And so I think within the past few years, those were incorporated thanks to work from the group at NOAA looking at coastal wetlands. On the greenhouse gas inventory side, we do every year work to improve the greenhouse gas inventory as we develop new versions. So we go back and recalculate the full time series where new data is available. One of the key areas that we're looking at for methane, which is an area that I focus on, is trying to better understand gaps between top-down and bottom-up studies and try to move towards a place where those estimates are converging. And so we can actually use the top-down data to kind of validate what we have in the inventory. So to do that, we're doing a number of things. So one is tracking both top-down and bottom-up studies. The kind of top-down studies, and there I'm meaning like satellites, towers, aircraft, they can provide a general indication of over or underestimates. The bottom-up studies can generally provide us directly the data that can change our estimates in one direction or another. So those have been incorporated into the inventory to improve estimates. An example of how these can somewhat work together for the distribution segment of natural gas systems, some studies have shown higher emissions than in the inventory. Some top-down studies. At the same time, a number of bottom-up studies became available also with higher emissions. We've incorporated them into the inventory, and then we kind of get closer to filling that gap. Also, to kind of help improve understanding of any differences, we developed in 2016, working with a group at Harvard, a gridded version of the national methane emissions in the inventory. We're working on developing an updated version of that, which at this point would include emissions for the years 2012 through 2019 based on last year's inventory. We're also thinking about ways that we can kind of standardize or automate this process to develop a gridded inventory along with the national inventory as we continue to make updates there. So yeah, that is an overview. We are at the point of developing a public review draft for the upcoming greenhouse gas inventory. So there's an opportunity to weigh in on the estimates. I'll also note that the greenhouse gas reporting program, which is the main source of data for the greenhouse gas inventory, will come out with a proposal on revising some of the methods there. And so that might be another opportunity for comment on that process, and another opportunity for us to improve data that will be used in the greenhouse gas inventory. Thank you.
Okay. Thanks, Melissa. Thanks, everyone. So we can now start discussion and Q&A. So we'll track questions coming up in the chat. I think everyone has access to the chat, so please post a question there, or maybe we can unmute you and you can just ask your question over the mic. So one comment that Arlyn has had is about sort of the panel is focused very much on anthropogenic emissions, and we wanted to highlight sort of the role that the biosphere plays in how we monitor and interpret atmospheric concentrations of the various greenhouse gases. And so we've sort of have envisioned two thrusts for the activity. One is more along the lines of sort of informing policy and better understanding the sectoral emissions and understanding the activity data, the emission factors, and sort of interpreting this with top-down information. But it would be good also to hear sort of a perspective on the second thrust, which is sort of how we can integrate these observing systems to better track climate carbon feedbacks. So I would ask Lori if you wanted to share a bit about your perspective on this second thrust for such an interagency activity.
I was busy typing a question, Ben. Could you repeat what you want me to comment on?
Well, if you could sort of say some of your ideas about the sort of the climate carbon feedbacks component of such an interagency observing system. And I think we've sort of focused quite a bit on the anthropogenic and the policy sort of motivation for this, but there's also sort of the second area that we haven't really discussed so far.
Right, that's actually the nature of the question I was typing. So I think where we're different from things like IGUS is our focus on understanding not only the anthropogenic emissions, but also how the natural emissions might be changing over time. And we all know that there's some parts of the world where carbon cycle feedbacks are of critical interest. For example, the Arctic and the tropics. In the tropics, we don't understand the carbon cycle very well or how it might be changing. So we hope that our interagency effort is, in addition to being about anthropogenic emissions coming from fossil fuels and industry, can we also say something about how the natural fluxes are responding to climate change? This is an important topic because it, if there's a lot of outgassing of carbon from the Arctic, for example, we have to make deeper cuts in anthropogenic emissions in order to stay on track for whatever climate targets we have. So keeping track of natural fluxes, of course, means that you need long time series. Measurement systems need to be maintained for decades. And, we need to keep estimating fluxes over time and improving our ability to do them with accuracy. The question I was typing was actually about NASA. NASA has a lot of space-based data sets that can be used to learn something about natural fluxes. For example, the vegetation temperature thing, I think it's called JEDI.
Ecostress.
Ecostress, yes. So some of these data sets are being used along with process models of carbon cycle fluxes in a data assimilation modeling framework to provide estimates that have been influenced by space-based observations of fluxes. These sorts of things could be extremely useful in atmospheric data assimilation and flux inversion systems. I wonder if there's a role for NASA in producing these kind of products. I know it's been said many times, operational is not NASA's business, but they do have some of these things. And, they might be useful. Does NASA see a role for providing these kind of estimates?
Yeah, of course, NASA wants to be involved. And I also wanted to point out that the global stocktake isn't just emissions, but it also includes the changes in the forest carbon stocks and agricultural as well, the AFLU. And so we have to understand the whole carbon system to know what is the human impact and what is the natural impact. And Lori, that was great to point out that we might need deeper cuts if the natural system feedbacks go against us. And so, maybe Mike has something to say, or Ken Jux is on the line, and Hank, do you guys want to say anything?
I can just say that, of course, it's something that we're interested in, and it's something that we would love to support. And there are a few mechanisms that we could use to do something like this. One is write it into a solicitation, for example, or the other is something called the Satellite Needs Working Group, which federal agencies can submit surveys if there is a need for a data product like you're talking about, Lori, that NASA data could be used to generate. They can submit a Satellite Needs Working Group request, and in the past, it's been very successful in getting additional funds into NASA to support operationalizing data products for other federal agencies. So it's something worth considering in that avenue as well.
This is Arlyn. I just wanted to clarify a little bit. The point that I was trying to raise is really that this panel today, either by design or just by the interest of the participants who drove the agenda, it's not a full cross section of the U.S. greenhouse gas and carbon community. So Ben talked about the USGCRP and the 13 agencies. We on this panel, we have a lot of representation kind of at the intersection of the atmosphere and the ecosystem fluxes and the anthropogenic fluxes, but we don't have representation from folks who study the deep ocean carbon storage or decadal scale accumulation of biomass. But NASA and the NASA Carbon Monitoring System are very active in those areas, and through the NASA Carbon Monitoring System have engaged with partners, other USGCRP partners, such as USGS and US Forest Service, that have contributed a lot to research in this area over the last 20 years. And so, you know, I just want to acknowledge that there's a lot of work, and you'll hear about it if you attend the NASA Carbon Monitoring System sessions that Peter has been plugging in the chat. And a lot of products are at the point where they're ready for a transition from research to operations. But there is a lot of low-hanging fruit, and the PAESS in this realm, this sort of intersection of anthropogenic and ecosystem fluxes with the atmosphere, that intersects very directly with the Paris Agreement and trying to support mitigation efforts.
Right. Thanks, Arlyn. So we have a question from John Caracas.
Yeah, hi, Ben. Is it okay if I just...
Yeah, please jump in.
Thanks, and thanks for organizing this session. It's great to see the interest across the agencies, and you've expanded to the international with the European Commission. And of course, I understand this town hall is focused on the U.S. interagency cooperation, but as we all know, carbon and other gases don't observe country boundaries, and so it's an international problem. And so my question for the panelists, if you care to address it today, is how can we better engage our other international countries and groups, such as China and India, who have observing systems on satellites and grounds? And I wonder if there aren't mechanisms that can occur at the more grassroots level of the scientists, such as through international professional societies and conferences. And so there are opportunities to perhaps leverage the other work that's going on around the world to attack this problem. It's important to us all.
Can I answer that question? I mean, I think that's a great question, John. And I think if we look at the weather enterprise, we have a model there. And the model is coordination of observations all over the world, developed countries helping less developed countries, fund measurement programs, timely sharing of data, which is not a situation we necessarily have right now. There is a WMO site where you can download greenhouse gas observations. However, if you go there, you find that the data sets are often not up to date, or maybe they haven't met the quality control methods of the WMO entirely. And, you know, so we could have more international cooperation, and we could look to the weather community for examples on how to do that. Of course, greenhouse gas observations, especially, you know, the in situ ones, they're labor intensive and they're costly. It's not like measuring temperature and precipitation. But I think one of the other things that sets this effort apart from other efforts is our focus on global carbon cycle issues. And that means we have to figure out how to work with our international partners.
Let's go to Richard's perspective on this through CAMS, and then to Arlyn.
Yeah, I agree with Laurie that it's a very important question, and we do think about it, how to put this in practice. And there's different elements to it. Well, you need to care about how do we collaborate on putting systems in place. So the observations, the modeling activities, but then there's also the user side. How do we connect with countries, especially in developing parts of the world that might not know directly what to do with the data, or they're not even waiting for the data. So we try to think about these different elements and try to see where we can work together, either through international frameworks, obviously there's CEOS, but CEOS also tends to be dominated by just a few countries. Then there's WMO, and then IGIS specifically, which has a bit more of an outreach to other parts of the world. And of course, WMO has strong heritage on the observation side as well. So it's not straightforward, but it's important. It's also to get acceptance of what we develop by the global community in the end. We can develop all these great systems and come up with numbers, but if it's not shared and not accepted by the global community, then there's probably not enough use to it. So certainly something we need to think more about, and we're trying to do it from our side to the extent we can, but there's clearly more to do.
Okay, Arlyn.
I just wanted to add that there is a lot of engagement with the U.S. agencies. I'm most familiar with NOAA via NESDIS and NASA's engagement on the CPAESS, which is the International Coordinating of Earth Observations. So they have a GHG task force under CPAESS, and NESDIS and NASA are both very active on that. And I know that on the AFOLU side, land use, there's a lot of engagement there internationally at the satellite level, because those investments are so big that that coordination has to happen. And I would say where we need to do better and where we have been limited by lack of support from, what I want to say is that having a presidential administration that has climate as a priority allows that to be a priority for NOAA and other agencies, so that we can work within our institutional framework to collaborate directly with, and hopefully there will be funding to back this up so that we can coordinate closely with other kinds of observational networks like the ICOS network in Europe. NESDIS is engaging, and NASA has engaged very closely with JAXA, the Japanese space agency. On the ecosystem front, NASA has a mission with India, NISAR, to look at, I think it's biomass and land use, but this is outside my expertise. So I mean, just kind of to say that some of these things that are lower level investments at the national level, they haven't had that same level of coordination. But folks from the European programs have done a great job of including and coordinating with people in the US by having representation on their advisory boards and, through the conferences and whatnot.
Yeah, and I guess I would also add where the national greenhouse gas inventories also come in with this sort of international perspective is that, the majority of the world's countries either don't have a national greenhouse gas inventory program, or the inventories are quite sort of far behind and out of date. And it makes it challenging to sort of add those up into a national or global aggregate to be able to understand the emissions and removals. And so part of the activity that Arlyn mentioned that is taking place within CPAESS is to try to build capacity for countries that currently don't have inventories. And then the challenge sort of becomes one about the methodologies that are used to develop those inventories, and sort of how we can integrate the newer observations from missions like NISA or JEDI that are directly measuring stocks, and how those can be sort of reconciled with the IPCC guidelines for how these inventories can be carried out. So I think, that there's a capacity building component to this that's necessary for sort of working toward the first global stock take.
So Ben, I think Melissa probably knows a lot about that.
Yeah, Melissa, would you like to add about sort of,
Yeah, so one of the very exciting things about the Paris Agreement is that it does require more frequent reporting from every country that's a party to the agreement. So for a lot of countries, maybe we have like 1 or 2 inventories up until now, but most countries starting in 2024 will have to report at least every other year, is my understanding. And so there is a lot of interest by these countries in improving their capacity to develop greenhouse gas inventories. EPA has an international capacity building program, and we're working with a number of countries to help them to build inventory systems from like just the system within Office, the QA, QC, and archiving pieces, up to like helping to get source specific data for implementing the estimates in the inventory. And so one of the things we focus on is developing sustainable systems, because I think a lot of these countries, because they've only done 1, 2, or 3 inventories in the past, a lot of times just have not implemented a system to keep going and keep continually improving, as the countries that have been required to do these annual reports have been doing.
Thanks. I think Lori has a follow-up for you, Melissa.
Yeah, I have a question for you, Melissa. And my question is, do you ever see the EPA routinely providing spatially disaggregated inventories for use in a global or regional data assimilation platform that's being run and updated continually? I mean, what would it take for the EPA to be able to do that?
So I think for the US at least, so we are looking at doing this for methane, and it's underway, and I feel like we've been saying any month now for a very long time, but I really think in the next 6 months or so, we'll have our updated methane gridded inventory product out there. There's not work underway on the other gases as far as I'm aware, and I don't know what that might take. My guess is that for some of the F gases, it might be an easier undertaking than methane, and for CO2, far more complicated. But yeah, I don't have a great sense of how much effort or funds or time it might take to grid all of the greenhouse gases.
I think some of the work that we need to do is to figure out which parts of some of these research systems, like the NASA carbon monitoring system and our carbon tracker, have a natural home in an existing agency and kind of fall within the scope or the mandate of the agency's current work. And then there are other pieces that don't have a natural home and that aren't within the scope of the EPA's mandate, for example. So in this case, so so far EPA hasn't been asked or required to provide spatially disaggregated, gridded estimates of CO2. But we need them, and NASA needs them too. But so, is it, what do we do about that? Is it incumbent upon NOAA to develop and operate, to take what has already been developed in the research realm by folks like Kevin Gurney and Lucy Hutira, where they have these really advanced gridded inventories, and they take into account the EPA's power plant emissions data, et cetera, to provide that information at the resolution we need to understand our atmospheric measurements. Somebody needs to operationalize that if we want to produce these products. And so that's something that I think it's incumbent upon our community and the USGCRP's Carbon Cycle Interagency Working Group to kind of map out where there are gaps. Another place is the IC, and folks in the audience here like Hank Margolis could speak to this. It's like there's a part of the land problem that is within the U.S. Forest Service's mandate in terms of managed forests and looking at things like above ground biomass. But then there's this whole host of exciting new ecosystem observations like evapotranspiration and new ways to track biomass that doesn't that really like sort of focus on the ecosystem point of view, and I don't see that there's an agency that has an operational mandate to do like ecosystem science currently, and that's somewhere that there's connections at the weather scale with respect to evapotranspiration, but then there are these longer term things that intersect with the realm of the Forest Service, but need further development to address this new societal problem. Or not new, but to develop operational capabilities, new operational capabilities to address these questions.
Thanks, Arlyn. 1:15. Richard, did you have a final comment before we wrap up?
Well, I can be really quick. It was just a comment on the gridded emission data sets, because in Europe we have a similar problem, or we had a similar problem, that most countries tend not to provide that because there's no interest in it for them, while we really need it for our modeling and data simulation activities. So we actually spent significant budget within CAMS on bringing all these data sets together and come up with both European and global scale inventory data sets that are consistent. So yes, you need someone to really do this. Otherwise you keep working with insufficient data for your own requirements.
Thanks, Richard. Before we wrap up, I'd like to thank everyone. I'd like to thank all the moderators, co-chairs, Ben, Poulter, Bruhwiler for this session, and all the panelists. And since this panel is about interagency cooperation and coordination, maybe I'd like to close out by reading some sections of the Global Change Research Act, which mandates, which is sort of our raison d'etre for the Carbon Cycle Interagency Working Group, for the Observations Interagency Working Group, for the US Carbon Cycle Science Program. So there I see two sections. One is the mandate to inform responses to global change, that we need to consult with actual and potential users of the results of the interagency program to ensure that such results are useful in developing national and international policy responses to global change. And then there's the other one on international research and cooperation, the mandate to cooperate with the Secretary of State in coordinating the federal activities of the US with programs of other nations and with international global change research activities. So I hope this helps a little in adding to the conversation. And shall we end? A big thanks to everyone and everybody who stayed with us throughout this 1 hour.
Thanks, everyone.
Thanks, everyone.
Thank you.
Thank you.